Hello dear students, welcome you back for lecture number 2 on the topic system of particles and rotational motion. So in the previous class we were able to understand what exactly is the translational motion and what is rotational motion. So in today's class we are going to study a concept of center of mass. Now this topic or this concept is the core of this entire chapter. Once you understand the center of mass, then things become very easy as we go deeper into the subject. So before wasting any more time, we will start center of mass. Now what exactly is the center of mass? We'll understand few examples and later we'll come back to the definition. So if you remember in the previous class I had given you an example of an rotational motion. If we just throw a ball on the floor, then ball will roll, and that rolling is again called as a rotational motion. Now assume there was a ball, it's rotating in this direction as well as it is traveling here, right? It's a combination of planar motion, you can tell, because ball is traveling in a straight line as well as ball is rotating. Now you know that I had taken two internal points, and if the two internal points, the line drawn after the motion or under the application of the force, if they are parallel, then it is called as translational motion, and if they are not parallel, then it is called as a rotational motion. As simple as that. Now you observe here is it's a rotational motion, right? Ball is rotating. But now see an interesting thing here. If there is a point A here and there is a point B here, right, and I'll draw a line here. After some while, since the ball is in motion, ball will travel certain distance, the A point will remain here only and B point may come somewhere here because motion is in this direction. If it is anti-clockwise direction, then it would have been here. Now you are observing one interesting thing here is all the particles are revolving around this point A. That A point is there only. If I draw a line, it somehow looks like a straight line only. But look at the other point. B was here, it went here, after somewhere it may be here, it may be here. What you are seeing here, if you take the velocity at this point, it will be in this direction. If you take velocity of this ball at this point, it is here. If you take velocity at this point, it will be here. Yes or no? But what about the velocity at this point A? It is always towards the direction of the ball. Yes or no? So this is one good example to understand a center of mass. So center of mass of a system of particle is a point in which the entire motion or entire mass of the system is assumed to be concentrated. I'll give the definition later, but let's understand little bit. So this point A is called as center of mass. Right? Are you understanding? Suppose if I give one more example for you, like I'll erase this, that A point is called as center of mass. Okay. Still we have not come back to the definition. Let us understand a little bit more analogy of this. Suppose if I have a ball, I spin that ball and throw it vertically upwards, right? It will travel certain sort of path and it will come back, right? Now since the ball is rotating and it's going upwards, every particle is tracing a circular path. Yes or no? But there is one point in that ball which is actually tracing a straight path. That point is a center of mass. Are you understanding? Are you getting? If I rotate this ball and throw it, if I spin it ball and I throw it upwards, so all the particles are tracing some sort of weird directions. Yes or no? Can you imagine this? Like I don't have ball right now to show you, but can you imagine if I spin the ball, all the particles around the ball are traveling in different random direction. But there is one point at that center of the ball. Imagine that the center of the ball, that point is nowhere rotating. It's always going straight away. Neither it is tracing any weird path. That point is called as center of mass. Center of mass. Understand one more example. In motion in plane, you might have studied a parabolic path. Like if I take my pen, if I take my marker only, if I take a marker, throw it in the space, how does the marker will traverse a path? It's a parabolic path. Obvious. Any object thrown into a space will always trace a parabolic path. All of you know it depends upon the initial velocity, the maximum height, the range, and these all factors you already studied. But when I throw this marker somewhere in the space, this will trace this kind of path. Yes or no? Are you able to imagine this? Please closely look into this marker. This marker is stressing a parabolic path. Every point on this marker are stressing some sort of weird direction. But this is the marker. This is the center of this marker. This is the center of the mass. And look at this point. This point is perfectly stressing a parabolic path. Are you understanding? There is one point which is perfectly stressing a parabolic path. Other points on the marker are stressing some weird direction. It's not perfect parabolic path. So that point in the marker is called as its center of mass. Like so far you are studying F is equal to ma. When you write net force F is equal to ma, what does it mean? Whose acceleration are you considering? If I take a ball, as I told you, every point on this ball will have different sort of acceleration. Yes or no? If ball is traveling in this direction, velocity is in this direction. At this point, at this particle, velocity is in this direction. At this point, velocity is in this direction. At this point, velocity is in this direction. So every time there is rate of change of velocity, and this rate of change of velocity is acceleration. But which acceleration are you actually considering? That is more important. So far you were just writing F is equal to ma, but to be precise, this acceleration is of that center of mass. That acceleration is of this particle center of mass, which is actually traveling in a straight line. This parabolic path, every particle is stressing different path, but that center of mass is perfectly stressing you that parabolic path. This dot is perfectly stressing that straight line. You might have studied this also. Momentum is m into v. Which v are you considering? Whenever you consider net momentum, what do you mean? Which velocity are you considering? When you throw a ball upwards, the velocity of every particle is different. Unless and until it's a translational motion, the velocity and acceleration will be different. If it was translational motion, they would have been same. But since it's a rotational motion, you observe one thing, every particle will travel with different velocity and different acceleration. Then which velocity are you considering? So this velocity is nothing but center of mass of velocity. Are you able to understand what exactly is center of mass? Please try to feel the concept. What exactly is center of mass? Let me give one more example. Suppose there is one block that is falling vertically downwards, and you have been given a task to stop that block, whatever wooden block it is, maybe wooden block of certain kilogram, wooden block of maybe 5 kilogram, which is falling vertically downwards. Now you have been given a task. Hold this box, don't allow the box to fall on the ground. Somehow you need to catch it. You will be given some 5 sticks. So what you do is you apply a stick here and here, and you are avoiding the wooden block to fall down from the ground. Yes or no? But this work, whatever you have done, that is anti-gravity work. You are doing work against the gravitational field, right? You are overcoming that gravitational field and avoiding that box to be not to fall down. Yes or no? But what if I give you just one stick and somehow ask you to stop this block? The things become very difficult now. The wooden block coming with 5 kilogram falling down to you, and you have been given a one stick, and somehow you need to stop it. So how you will do? You will try with different methods. You will hold a stick here, it will fall this side. If you hold a stick here, wooden block will fall this side. If you hold this, it will fall this time. Every time it falls. But on that wooden block, there is one point where the entire mass of that wooden block is assumed to be concentrated, and somehow if you are lucky enough and if you hold that point perfectly, trust me, that wooden block will not fall back on your head. So that is center of mass. So these few examples can we relate now? All of you have bikes, right? The bikes have been given a side stand. Yes or no? Now that side stand is, I don't know to draw the bike, but somehow I'll draw it. Okay, this is no, we will laugh now. Now the bike has a stand perfectly placed between two wheels. Yes or no? the stand itself is holding the entire mass of the bike. Are you understanding? Now it is very important ki where you place that stand. Most of the bike you see ki the stand is placed in between those two tires. It is not placed on the rear tire or on the front tire. If it is on the rear tire, bike will definitely fall down. If it is on near the front tire, definitely bike will fall down. But that stand, that is perfectly positioned at the center, at that particular point where the mass is uniformly distributed. This is exactly what a center of mass. So how can you define a center of mass? Center of mass. I'll erase and I'll write the definition for you. So, center of mass, popularly written as short form, center of mass of a system of particle is a point in which entire mass of the system is assumed to be concentrated. Or you can write it's a point at which entire mass of a system is uniformly distributed. So what exactly is the center of mass? It's a point where the entire mass of the system is assumed to be concentrated. Okay, like if this is the system, if it's a uniform density system where the mass is uniformly distributed of length L. So I take this. So basically the task of finding center of mass is very important. Usually we see ki where the more mass has been concentrated, or we straight away go to its geometrical shape. Okay, now if we look at the rod, anybody can tell you ki this is the center of mass of this rod. Are you understanding? So center of mass of system of particle is that point. It's that one point in which entire mass of the system is assumed to be concentrated. So somehow if you get that point, then that point is called as center of mass. Are you understanding? Getting my point? Suppose if I have this book, I need to hold this book in one very particular manner. I cannot hold this book in this edge. It fell down. If I hold it here, it will definitely fall down. But if I hold somewhere at the center, see, easily it balances. So the entire mass of this book is assumed to be at this common point. And that point is known as center of mass. That point is known as center of mass. Are you understanding? Are you getting my point? Okay. Or you can tell that is a point where the mass is uniformly distributed. Suppose if this is a rod of 10 kilogram of length L, tell me where is the center of mass? You will tell exactly here. You will divide this rod into two parts. You will tell ki 5 grams here and 5 kilograms here. So from this point, the mass is uniformly distributed equally. Are you understanding? If I take a triangle, where is the center of mass of a triangle? Equilateral triangle. It's at the centroid of the triangle. If I take circle, this is the center of the circle. If I take square, this is the center of mass. But provided whatever I am showing you, provided this is of uniform density. If it is not of uniform density, then we need to do the calculations. Okay, there is a different method to do that. But for as per your syllabus, we usually consider a uniformly distributed mass, where the mass is not distributed unequally. We assume ki, like if I take a hollow ring, it's a hollow ring, then center of mass will be here at the center. Now there is a question whether the center of mass always lies inside the body. No, not necessary. In case of hollow ring, the center of mass lies outside the body. Yes or no? I'll erase this. So suppose if I have a triangle, centroid of the triangle is my center of mass. If I take a rectangle or square, we will see where the mass is equally distributed. If I have a circle, here is the center of mass, planar circle. Okay. If I have a ring, hollow ring, then in this case center of mass will be here. Are you understanding? If I have a L rod type of shape, so center of mass will be here. So from these two examples you can easily understand कि not necessary center of mass should be at the should be inside the body. Not necessary. In case of hollow ring, the center of mass lies outside the body. Hollow ring, it's a hollow ring, right? It's a hollow ring. All of you can remember, imagine hollow ring. So the vacant area, there is the center of mass. From this point, the mass is equally distributed at every point equally. From this point, the mass is equally distributed, or entire mass of this system is concentrated at this point. At this point, at this point, at this point, entire mass of the system, entire mass of that system is assumed to be concentrated. Are you understanding? Got it? So not necessarily center of mass should lie inside the body. It may also lie outside the body. Only thing is you should know where exactly is the center of mass, and that from that point you should take care that mass is uniformly distributed from all the sides equally. Got it? But from examination point of view, they will just ask what exactly is center of mass, and they will ask you whether the center of mass will lie inside the body or outside the body or both. So it depends upon what kind of material you are taking. If it's a hollow ring, then it may lie outside. If you are taking a triangular lamina, then it may lie inside the body. Are you understanding? Now, how do you represent center of mass in terms of position vector? In terms of position vector. Now, let us understand this. Suppose I have two masses M1 and M2 separated by certain distance D. Separated by certain distance D. This is of 10 kilogram and this is of 10 kilogram. Tell me, where is the center of mass of this body? Definitely it will be here. So D by 2 by here and D by 2 from this side is the center of mass of this body, right? Suppose there is one more body of mass M and here mass 3M, or I would write 6M. Where is the center of mass of these two bodies? You should take one reference from where you are measuring. Center of mass will be somewhere near this side, because it is 6 times of M and this is only M. So more mass is assumed, more mass is concentrated due to this body, not by this body. So center of mass will be also shifted towards this body. Are you able to get that point? Okay. So now let us find out exactly the position vector of the center of mass. Now suppose I draw this. This is my x-axis, this is my y-axis, this is my origin. Now suppose there are two bodies of mass M1. There is one more body of mass M2. Let me, if they are separated by certain distance, M1 and M2. It has a position vector R1 and this has a position vector R2. Now how do you find exactly center of mass of this body? Now this M1 and M2 are separated by certain distance. So the center of mass, definitely it will be here somewhere. RCOM, the line joining these 2 points. Are you understanding? So center of mass is given by RCOM in terms of position vector is M1 R1 plus M2 R2 divided by M1 plus M2. Are you understanding? So remember this formula. This formula is not there for derivation, but you have to remember this. So R center of mass in terms of position vector is given by M1 R1 plus M2 R2 divided by M1 plus M2. So if there are 3 or more particles, what would you write? So in this case you will write M1, M2, M3, M4 and M4. So if I write in generalized form, R center of mass can be written as summation of mr position vector divided by summation of m. Are you understanding? Please try to understand this. Got it? So suppose if I have two masses m1 and m2 separated by certain distance, then the center of mass will lie somewhere between these 2 points. We are not sure exactly whether it is at the center or no, that later we'll do the calculation. But right now you understand ki by our analogy we'll predict it lies in between these 2 points. Definitely it will not lie here. It will not lie here because this mass will also contribute something to it as well as this mass also will contribute something to it. So center of mass lies here. So center of mass in terms of position vector is given by m1 r1 plus m2 r2 divided by m1 plus m2. If there is system of 3 or more 4 particles, then just go on doing it, m1 r1 plus m2 r2 plus m3 r3 and so on. So in generalized form I can write summation of mr divided by summation of m. What is r? R is the position vector. It is always important to take the origin. Whenever you are considering the center of mass, it is always convenient or it is most important to consider an origin. Without origin, you cannot define center of mass perfectly. Okay, not necessary ki origin can be anything. It's all left up to you. You can take whichever origin you want. Okay. Now we have seen one interesting thing here is R center of mass is given by m1 r1 plus m2 r2 for system of 2 particles r m1 plus m2. Got it? But what if I write in terms of x coordinate, x center of mass? Because the object might be in x axis, y axis or z axis. So in that case you should write m1 x1 plus m2 x2 divided by m1 plus m2. Similarly, y center of mass, how will you write? m1 y1 plus m2 y2 divided by m1 plus m2. Again, it depends upon how many systems you have. If there are more than 2 or 3, just go on writing it. And in terms of z coordinates, m1 z1 plus m2 z2. Show a vector because it sets the direction m1 plus m2. Got it? Okay. Have you understood this? Okay. So once you understand this, we'll do few problems on this so that things will be very much clear to you. So just remember the definition of center of mass. It's a point where the entire mass of the system is assumed to be concentrated. And how do we get it? We basically look at it geometrical shape, or we look at where the entire where the mass is concentrated on the which side. Okay, and in terms of position vector we can easily get this. Okay, once we do the sums, things will be very clear to you. So shall we start doing few problems? Center of mass in terms of RCOM, position vector, RCOM, position vector. Okay. Now suppose there is one body, let this be x-axis, y-axis, this be origin, and this might be the coordinate 1 0 and these are 4 0. This is mass m1 and this is mass m2. This is mass m1, and or else better I'll give this is as m and this I'll give any number you can take. We can take 2m. Okay. Now find the center of mass of this object. Find the center of mass. Have you understood the question? These are the coordinates, x coordinate, y coordinate. There is two objects of mass m and there is one more object of mass 2m. Where is m? Y, 0 means it is along the y-axis. X-axis. Along y-axis, its coordinates are 0. And this object is somewhere 4, somewhere near 4 units, 4 meters, kilometer, whatever it is. And it is nowhere concerned with the y coordinate. It's a 0. So how do you calculate its center of mass? Obviously, without calculating y center of mass will be 0. Z center of mass will be 0 because the object is nowhere concerned in y-axis and z-axis. Look here, there is no z-axis to represent. Definitely you can write 0. Y-axis 0 and 0, so it will be 0. But what is its center of mass with respect to x coordinate? So how we will write? What is formula? M1 x1 plus M2 x2, show the vector, divided by M1 plus M2. So how we will get x center of mass will be equals to what? Before solving the sum, you only tell me where will be the center of mass. Definitely the center of mass will be somewhere near this 2m. It will be very much closer to the 2m because this is m, this is 2m. So more mass is here. So center of mass will be somewhere near 2m only compared to 1m. So let us see. What is m1? M. What is x1? 1. What is m2? 2. What is x2? 4m. 4. m1 plus m2, 2m plus m. So this will be what? X center of mass will be m plus 4 2s are 8m, 2m plus m will be 3m. So x center of mass will be what? 8m plus m will be what? 9m divided by 3m. 9m divided by 8m plus 3 1s are 3 3s are. So x center of mass will be what? 3 units. X center of mass will be what? 3 units. So it was origin, this was 1 unit, this was 2 unit, and this is 3 unit. So look here, x center of mass is somewhere near this third coordinate. Are you getting my point? So center of mass of these two particles m and 2m is somewhere near 3. Got it? And without even calculating, you can straight away write y is 0 and z is 0. Or simply equate the terms. What is y1 here? 0. y2 will be what? 0. 0 into anything will be 0. Got it? Are you understanding? Okay. Have you understood? So we'll do next problem. No. Suppose there is one more body. There is body of mass m and there is one body of mass 3m, and they are separated by certain distance a. They are separated by certain distance a. Okay. And find the center of mass of this body. Find the center of mass of this system of two bodies. How will you find? Now, as I told you, very important thing, it is always convenient to use the origin. Origin you can take anywhere. You can take any origin you want. Okay. So for my instant, I will consider this as my origin. So I will consider this as 0 0 coordinates. This is my origin. What will be this coordinates? Come on, tell me. What will be this coordinate? A and 0. A and 0. Is it correct? Are you understanding? A and 0. Are you following my step? This object is distance A. So A coordinate. This object is nowhere concealed in the y direction. So these will be my coordinates. Please, have you understood the coordinates? There was a two system. In the previous problem, I had already given you ready-made coordinates. In this problem, there are no coordinates. So how do you do that sum? You have to take anything of the origin. Either you can take this as origin or this as origin. For my instance, I have taken this as origin. So 0 0. X is 0 and y is 0. X is 0, y is 0. So here x is how much? A. It has traveled how much distance? A. What about y? No. So again, now you will find x center of mass. Come on, right? M1 is M only. R1 0 plus. You tell me before doing the problem. Come on, you tell me where is the center of mass? Obviously, this is 3 times of m and this is m. So obviously, the center of mass will be somewhere here. It will be more towards the 3m. Yes or no? Got it? So let us see after my calculation whether do we get the same answer or no. So what about this? M2. M2 is what? 3m. What are the R1 coordinates? A. Y is 0. What is M1 plus M2? 3m plus m. So I'll do directly right, or I'll write m plus 3m. So x center of mass. Why I'm taking only x? Because there is nowhere concerned with the y coordinate. So m into 0 will be 0. 3m a plus 3m plus 3m will be what? 4m. So m gets cancelled. So what is x center of mass? 3 by 4 of a into a. So what do you mean by this? A is what? The total distance. And what is 3 by 4? It is almost 0.75% of A. Got it? So if I look at this exactly is the 50%. This will be what? Half of that 25%, and what will be half of this? 75%, and this is total 100% of A. So before doing this sum, we have assumed it that the mass should be concentrated somewhere near 3m. More mass is concentrated towards 3m. So this will be the center of mass. So if you hold at this point, if you were holding at the center, it was imbalancing. If you somehow hold at this point, it will again balance if they were pivoted by both ends. Are you understanding? So this is the importance of center of mass. You can easily tell where the entire mass of this system is concentrated at this point. Entire mass of this system is concentrated at this point. Little bit difficult to understand, but the more we practice, the more perfect we will be. We'll do one more problem. So, okay, another problem we'll do. Suppose there is a square. Okay, here we have mass m, here we have 2m, here we have 3m, and here we have 4m. Okay, 2m, 3m, m, and 4m. Now suppose there is a rectangular box of uniformly mass density. It's not a uniform mass density. Mass is not distributed equally here. Here we have m, here we have 2m, here we have 3m, here we have 4m. Now before solving this sum, you try to imagine where will be the center of mass of such object. You use your common sense and tell me. Here mass is less, definitely this part is nothing to do with the center of mass. It will contribute, but it will be not towards this point 3m. So somewhere the center of mass will be dominated more by 4m and 3m. So somewhere it will be in this region only. Yes or no? Are you understanding? Now it is very important to take the origin. You can take this as origin, this as origin, this as origin, or this as origin. Left up to you. I'll take this as origin 0, 0. And now it is a square. It's a square, okay? It's a square. So if it's square, then it will be of equal side. So if this is A, definitely this also will be A. Side into side. So what will be this coordinate? What will be this coordinate? A0. Am I correct? It will be A0. Yes or no? It has traveled X distance. It has not traveled Y distance. It is 0. Now look at this point. What will be coordinated? A and A. It has traveled X. It has traveled Y. A and A. What about this? 0, A. It has just traveled which coordinate? Which coordinate? See, are you understanding? 0, A. Are you understanding, students? How to write the coordinates? Okay, clear. Now, students, let us apply this. Okay, now this coordinate, are you able to understand, right? With respect to this, 0, 0, origin, A0, x-axis, no with the y-axis, x-axis and y-axis at this point, certain distance y and certain distance x. At this point, x is 0 and y as A. Now come on, find x center of mass. First we will find x center of mass. Come on, use the formula. I will take m1, m2 and this. So what will be this? m1, 3m, r1, 0. I'll erase and I'll write it properly. So see, this will be A and A of this coordinate, okay? So that I'll get a more space to write. Now x center of mass will be what? At this point, m1 is 3m, r1 is 0 plus what is m2? 4m. I'll write 0 here. Okay, 4m plus x1. I'm taking x coordinate, so it will be A plus m, x coordinate A plus 2m, x coordinate 0, divided by m1 plus m2 plus m3 plus m4. Remember the formula. So what will be this? 3m plus 4m plus m plus 2m. So what is x center of mass? Come on, tell me. 3m into 0 will be 0. Are you understanding? 4m A plus m A. These are position vectors. It is always better if you show an arrow mark, so you will easily understand. Okay. What is 2m? 2m into 0 will be what? Plus 0. Got it? So add this 4m, 7m, 8, 9, 10 m. Are you understanding? Got it. So what will be x center of mass? So 4m plus ma. This will be what? 5 ma divided by 10 m. So m gets cancelled. 5 ones are 5 twos are. So what is x center of mass coordinate? It is 1 by 2a. 1 by 2a means what? X coordinate. I'm just telling you about x coordinate. So x coordinate will be what? 1 by 2 half. 1 by 2a. Let us take y coordinate. Let us take y coordinate. Now you can also try along with me, okay? Shall I erase this? Will you remember x is what? 1 by 2a. Now I'll erase this. And same way I'll do for y center of mass. Y center of mass. So y center of mass will be what? Again, same formula. M1 R1. M1 is 3m. What is M1 R1 for y coordinate? 0 plus M2 R2 4m. What is y coordinate here? 0 plus M R1. What is this coordinate? A1 plus this 2m. What are those coordinates? Y, A. Are you understanding? 2m R1, this one. Got it? Divided by same thing. 3m, 4m, m and 2m. I think it was 10m if I'm not wrong. Correct? Yes or no? Or you can do it. Add those 4, 3, 7, 8, 9, 10. Okay. So y center of mass will be what here? 3m into 0 will be 0. 4m into 0 will be 0. Look, y coordinates are 0 here. 0, 0. Are you understanding? Plus ma plus 2 times ma divided by 10m. So y center of mass is what? 2 ma and plus 1 ma. This will be what? 3 times ma divided by 10 m. So gets cancelled. So y will be what? 3 by 10. Position vector is a. Position vector is a. So what is 3 by 10? If I solve roughly, 3 ones are 3, 3s are 9, and 3 point something I'll get. 3.3 something I'll get. Okay. Are you understanding? So what is y coordinate? It is 3 point something. So why it has not traveled more distance? It is somewhere here. Are you understanding? 3.3 of a. 3.3 of a. So how can you write center of mass of this? So of this system is 1 by 2a, and with respect to y coordinate it is 3 by 10a. So is it not? The center of mass will be somewhere here. Y coordinate. Yes or no? 3 by 10 of a. Got it? 3 by 10 of a. So before doing that also we can easily judge. More mass is concentrated here. 2m and m. Here the mass is less. So center of mass will be somewhere here. In x coordinate it is a by 2, and at this coordinate it is 3 by 10 of a. 3 by 10 of a. Are you understanding? So these are the most easiest way to find the center of mass. So I'll give you one problem for homework. You can write those answers in your comment sections. Okay. You can write only the coordinates because you cannot show the solution. Okay. You take similar kind of problem and try to get its center of mass. Suppose there is a body of 6m, 8m, 3m, and take 5m. Okay, mass, and this is a square only. It's not looking like square, but assume it is a square of side A, of equal side A. And please tell me your answer in the comment section of x center of mass and y center of mass. I'll be waiting for your answer. Okay, you have to simply use the formula summation of mr divided by summation of m. Depend upon how many are these masses involved. If there are more than 2, 3, go on taking this. One interesting thing here is that if both masses are of equal weight, then it will be just R1 plus R2 divided by summation of R1 and this. Okay, that also will do. This kind of problem also will do it. Okay, have you understood? So I expect you to do this problem. Okay, and make sure you write your answer in the comment section. Just try it. Got it? Okay. Now here we are going to study one more. So this is all about the center of mass. The most important application of the center of mass is It helps us to understand a complex system into a simpler way. Like if you take a body, any body, that body is made up of n number of particles, and studying those particles motion is highly next to impossible. So what is the best way to study the motion of any particle, or to study the behavior of any particle? Just study its center of mass, and center of mass will give you the correct behavior of the entire particle. So instead of searching every particle, rather focus on the center of mass. The center of mass will give you the answer in very perfect way. And center of mass is the only thing here where the Newton's law are totally 100% valid here. If you don't consider center of mass, in some cases you will find that Newton's law are been violated. So whenever you study any object's motion or behavior in terms of center of mass, you will always find that Newton's law are 100% successful here. And things become very easy when you apply Newton's law rather than applying any complex mathematics. Are you understanding? And you can study the behavior of any complex object by just studying its center of mass rather studying the entire complex. This. Got it? Now center of mass, if you look from board's point of view, it does not carry more weightage, but it will definitely help you in the competitive exam. Definitely questions will be asked from center of mass. Got it? So in exam point of view, they will straight away give you very simple problem, or they may just ask you even a definition. Got it? But try to understand the concept exactly what I am trying to tell you is. Okay. Now here we will finish one small concept, that is center of gravity. Center of gravity, which is a cousin of our center of mass only. Center of mass is COM and center of gravity is COG. Now again, the name itself suggests center of gravity. All of you are familiar with the gravitational force. Throw the marker upwards, it falls down. What is the reason? A gravitational force. Gravity is acting everywhere. Whatever weight we are experiencing, that's a gravitational force. How we calculate the weight? W equals to M into G. So this G is determining your weight. Unless you are on the surface of the earth, this value of G is 9.8. Unless you go to the Himalayas or polar regions or any other equatorial region, there is a slight variation in the G. But generally we take G as 9.8. Now what exactly is center of gravity? Center of gravity, again, center, name itself, center, and what? Gravity. Center of gravity is a point in which entire center of gravity is a point at which entire weight of the body is assumed to be concentrated. Center of gravity is the point at which the entire weight of the body is assumed to be concentrated. Definitely your whatever weight is there, that is determined by the gravitational pull. Obviously 9.8. Somebody obsessed by their weight. Somebody will not talk to it, okay? It may go personal, okay? But now, center of gravity. It's a point at which the entire weight of the body is assumed to be concentrated. Now, we as a human being, we have a weight, right? But the entire weight is just concentrated at one point, at our center of mass. If you look at human body, the navel, what we have, there the entire mass is assumed to be concentrated. From that point, the mass is equally distributed. Got it? Are you understanding? Now, center of gravity is a point where the weight of the body is assumed to be concentrated. Remember one thing, for smaller objects, smaller in the sense, I consider elephant also as a smaller object and ant also a smaller object. When I talk larger distance, means I am talking about a height of 1000 meters or 10,000 meters. So for smaller object, the center of mass and center of gravity will always coincide. For smaller object, the center of mass and center of gravity will always coincide. But what if the objects are at higher distance? Suppose, try to understand this example. What exactly is center of gravity? Suppose there is a tall building, a very tall building, and this building has certain mass. Okay, the mass is 1000 or 10,000 of tons. Okay, tell me where will be the center of mass of this building? Obviously here. Yes or no? Obviously here. this point is the center of mass. You will tell ki the weight, the center of mass, this will be what? From here it will be equally distributed. Got it? If the mass is 1000 tons, so here 500 by 2, m by 2, and here 5 by 2. So this is the upper part and this is the bottom part. Now, but you know what interesting? Imagine this building is in the Himalayas, which is already 8,800 and somewhere approximately 8,000 meters above the sea level. 8,000 meters, okay, not 800 meters. So approximately 8 kilometers above the sea level. So definitely you have studied in the gravitation topic, or even if you are not studied, you can use your common sense. As we go away from the surface of the earth, the gravitational pull becomes weaker and weaker, and at certain point, at certain height, maybe somewhere near 6,400 kilometer, the acceleration due to gravity becomes zero, and in that case you feel weightlessness. So one thing is quite clear ki as you go above the earth's surface, the value of g goes on decreasing. Yes or no? It goes on decreasing. So suppose at this point the value of g is this much, and suppose that building is at very high position, okay, where the gravitational effect is actually seen. So here gravity will be decreased by g by 2. At this point gravity is g, and at this point acceleration due to gravity g, it becomes half. So in this case, if I want to calculate the weight of this body, what will be weight of this body? Weight of this body m into g. So substitute now, m, g, and 2 2s will be 4. And in this case, weight will be what? mg by 2. Look at the both cases. You are finding there is a difference in the weight. Here weight is mg by 2 and here mg by 4. Why? Because you are on the top of the building. So I don't say top of the building means what buildings you see in the Belgaum city or whatever it is. I am talking about such a height ki unimaginable height. Imagine you have built a building, 100 feet tall building on the Himalayas, which is already 8,000 meter high, and plus your building height is also adding. So obviously there will be value of g will be not 9.8 here. At this height, at very big height, the value of g will become, it will be definitely less. I will assume it has become half. So in that case, I will calculate the weight. So here weight has become less. Yes or no? Weight has become 4 times of less, and here it has become half because it is at this point. So in this case, the center of gravity will not lie where the center of mass is, but center of gravity will lie somewhere here. It has to be still down. It has to be still down, and if you go above and above, the center of gravity becomes 0 and it goes on decreasing. Are you understanding? Got it? Okay. So this is all about center of mass and center of gravity. Don't concern more about center of gravity. They usually ask any question from center of gravity, but it is very important to study the center of mass. Okay. I hope you have followed today's class. Try doing those sums, whatever I have solved it, and try with some different methods also. There are various methods you can use and get me the answer, whatever questions I have asked. Okay. So thank you. We'll meet in the next class.